2025 A-level combined mathematics paper 2 part A question number 4. This question usually has to do with power. The question says a car of mass 1250 kilograms is moving at a constant speed of 32 meters per second on a straight horizontal road against a constant resistance of 1000 newtons. The question says show that the power generated by the engine of the car is 32 kilowatts. Then the question goes to another section where it says now the car moves downwards on a straight road inclined in an angle of sine inverse 1/5 to the horizontal against the same constant resistance of 1000 newtons, and then it says obtain equation sufficient to determine the speed of the car at an instant when its acceleration is 4 meters per second squared and its engine working with a power of 20 kilowatts. So we need to once again, similar to the previous question, obtain equation sufficient to determine the speed of the car. This means that we don't actually have to find the speed of the car directly. We can instead just find a bunch of simultaneous equations that you can use in order to find the speed of the car. So now, if we consider attacking this problem, at the start, if we consider the horizontal road, we have a straight horizontal road and we have a car on it. So I'm going to draw a horizontal road and we're going to draw a car. So considering this car, if the car is moving in the forward direction, it's moving at a speed or a velocity of 32 meters per second. But if you consider its acceleration in this direction with a double arrow, that value is 0 meters per second squared. So we can see the car is not accelerating, but it's moving at constant velocity. If we consider the forces acting on the car, since the car has a mass, it's going to have a downward force of 1250 G, and it's going to have an upward force of again the same value, but we're going to leave it as R for now. Now additional to this, as we said in the question, it has a constant resistive force of 1000 newtons against it. So if it's moving in this direction, then the force is going to be in this direction. So you have 1000 newtons of resistive force against it in this direction. Now additional to this, in the forward direction, there is some force called the driving force which is coming from the engine, and that force I'm going to represent with F underscore D. Or maybe F sub D. We'll represent with F sub D. So F sub D is going to be the driving force. So I'm going to say up here, let F sub D be the driving force. So this force is obtained from the power of the engine. Now if we consider the forces involved and we apply F equals ma, F equals ma in the forward direction, we can see that the total forces are going to be Fd plus negative 1000 newtons, since the 1000 newtons in the reverse direction, so we have minus 1000 newtons is equal to ma, which in this case the mass is 1250 kilograms, but the acceleration is 0 meters per second squared, which then gives us 0 on the right hand side and Fd minus 1000 on the left hand side, giving us that Fd is equal to 1000, or rather 1000 newtons we could say, but I'm going to say 1000 for now, and I'm going to call this Fd newtons on the front here, and I'm also going to put newtons to this force and this force as well. So now we have that the driving force Fd is 1000 newtons. Now from what we know about power and force, we know that power is equal to force times velocity, P equals Fv. If we apply this to this situation, we can see that the power value of the engine of the car is going to be the driving force, which is in this case 1000 newtons, multiplied by the velocity of the car, which in this case is 30 meters per second. So if you multiply 32 meters per second, and if you multiply, this is going to be 32,000, which is going to be 32 kilowatts. Unit of course being kilowatts, since a newton times a meter per second is going to be a watt. And of course when we remove the 1000 here and we write 32 thousands as 32 kilo, we get 32 kilowatts as our answer. So this is the answer for the first part of the question. We have shown that the power generated by the engine of the car is 32 kilowatts. Now for the second part of the question, as I said, we only need to obtain equations. We do not need to solve for the value. So if we consider the situation, we have a car moving downwards on a straight road inclined at sine inverse 1/5 to the horizontal with the same constant resistance of 1000 newtons, and additionally we are also given that the car is accelerating at 4 meters per second squared and the engine has a power of 20 kilowatts. So if we mark all of this out, we can see we have a car which is going down a slope like this. It is going at an angle of sine inverse 1/5, so I can label this as sine inverse of 1/5. So this is the angle we have a car like this, which is going down the slope at a velocity which we don't know what we want to find, which I'm going to call v0, and an acceleration which we do know, which I'm going to mark with double arrows as being equal to 4 meters per second squared. Now, considering all of the forces acting on this car, there is a downward driving force in this car which I'm going to call Fd dash. I'm not going to call it Fd because we already use the symbol Fd up here. Now, additional to this, we also have the constant resistance force that acts upward of 1000 newtons, is always acting in the opposite direction of our motion. Additionally, we also have the downward gravitational force of 1250 kilograms times g, and we also have a normal reaction from the road, which I'm going to label for now as R. So these are all of the forces that we have. Now, from this, if we want to make a bunch of equations, one of the things we can do is to use power equals force times velocity. We can rearrange this to get that force is equal to power divided by velocity, which in this particular situation we can use to find Fd dash. Since Fd dash is the power of the engine, Fd dash is going to be equal to the power of the engine divided by the velocity of the engine. So if we consider the power of the engine with 20 kilowatts, so the driving force Fd dash is going to be equal to 20 kilowatts divided by the velocity of the car, which is in this case v0, which I can rewrite to be 20,000 watts divided by v0. So this is one of the equations we can use. We can use the fact that the driving force Fd dash is equal to 20,000 divided by v0. Now after this, if we then consider the other equations that we can make two more equations in this situation using F equals ma. If we consider F equals ma, for this setup, we can make two equations, one in this direction and also one in this direction. Now if we make these two equations, we can see the equation for the forces in this direction is just going to give us R and 1250 g. Now that is not all that useful for finding the velocity v0. However, the other one in this downward direction does give us some help for finding v0, since there we are relating Fd dash, this force and this force, which will directly give us Fd dash, which if we substitute into here, we can see we have one force equals one value divided by v0, which is what we want. So for F equals ma, we only really need to apply it in the downward direction down the hill. So if we do this, we can see down the hill we have a force of Fd dash. We have also a force of 1000 newton, but that's up the hill, so it's actually negative. And we also have a component of the 1250 g, which is acting down the slope. So if we consider what we have, it's going to be the sine of this angle, and since the angle is sine inverse of 1/5, the sine of the angle is going to be 1/5. So if we consider what we have Fd dash acting down the slope, we have negative 1000 newtons since that's acting up the slope, and then we have a component of the 1250 g, which is the sine component. It's going to be the sine of sine inverse of 1/5, which is going to be 1/5, so multiplied by 1/5, and this is equal to ma. M is 1250 and A is going to be 4 meters per second squared. So this is our second equation. Now we can see using these two equations, we can substitute for Fd dash in here with values that we do know, and when we do that, we get one value equals 20,000 divided by v0. We can rearrange to get v0 equals 20,000 divided by Fd dash, and we can obtain our answer. Now we ourselves do not need to obtain this answer, we just need to show that it is possible to do so. So that is going to be all we need for this question. We have obtained equations sufficient for the second part, and for the first part we obtained the power of the engine. Now finally, if we consider the marks awarded for this question, for the first part, when you apply F equals ma in order to find the driving force is equal to 1000 newtons, for all of this you get 5 marks. Then when you apply P equals Fv and you get P equals 1000 newtons times 32 meters per second, which is going to be 32 kilowatts, you get another 5 marks. For the second part of the question, when you draw the diagram and you figure out that from P equals Fv, you can find that Fd dash is equal to 20,000 divided by the velocity, you get 5 marks for this. And finally, when you use F equals ma down the slope and you obtain that Fd dash minus 1000 plus 1250 g times 1/5 is equal to 1250 times 4, you get a total of 10 marks for that entire line. So for all of this, you get 10 marks. And that is going to be all for this question. So I hope you enjoyed. If you have any feedback, post in the comments down below. Thank you for watching and goodbye.